So we want to continue today to look at ways that we can generate equations for surfaces that are surfaces of revolution. Now, when Jack gave us his equation here for the paraboloid in question 2, he said that he was analyzing cross-sections like we've done before in order to make sure his equation was correct. Okay? So our goal today is going to be to look at a different way to analyze the situation to see if we can come up with equations. Because sometimes we have cross sections that we don't have names for the shapes. Okay? They might not be an ellipse or a circle or a parabola. They might be some other shape that we don't have a specific name for. Okay? So how could we come up with equations in another way? So what I would like you to do right now is to do questions 5, 6, and 7, okay, in your groups, 5, 6, and 7, with our goal of thinking about another way that we can generate our equation for the surface.
So if x would still be, so if z equals, so if z is 5 and then y is 25, that means that, how would y be 625? Oh, okay. Sorry. 625. Then when z is 5, x also has to be 625. Okay. Does that make sense? So then our point would be 625, 625, 5. Okay. Do you use that point?
Yeah.
And then using that rotation, the equation from here is always x squared plus y squared equals r squared. And then we just use algebra to derive, to simplify everything else so we can get rid of the r term.
Aha. Okay. Okay. Are we following the algebra?
Yeah. I mean, it's not complicated.
The radius is a function of the x. Okay, so if you let's just look at this, right? Yeah. So you're gonna have a parabola on the xz or the yz plane, and then the radius is gonna be the distance from the z-axis of any point, right? Yeah. And in order to determine the coordinate, you're gonna have like z equals x squared, for example, right? So you're gonna have to use z in order to determine the coordinate, and then x is gonna tell us the distance from the axis, which makes it a function of z.
Of z, but
to get r.
If we're saying that z, well, the z coordinate, the square root of the z coordinate, assuming that it's x squared plus y squared plus z. Okay, let's take the equation x squared plus y squared plus z equals 0, right? No, minus z. Yeah. Let's say minus z. Okay. So then we say x squared plus y squared equals z. So then the square root of z equals r, right?
Yeah. Okay.
Right?
Yeah.
But what does it tell us about the graph?
Well, it'll tell us
That
like
tells
the influence, like the circle that it could make in the parallel, or in the plane parallel to the XY plane. So like the actual the rotation. Okay, that makes sense.
So, 7. Use algebraic and geometric reasoning to develop a possible equation for that. We have to do. Oh, I didn't even see what else. Explain why z is equal to x squared plus y squared. So you know that z is equal to r to the 4th, which means that z equals parentheses r squared squared. Yeah. So then r squared equals x squared plus y squared. So then z equals quantity x squared plus y squared squared.
But this would be like x squared y squared plus x to the 4th plus x squared y 2x squared y squared plus y.
Well, if you go back over here, where we explain why x squared plus y squared is equal to r squared. So we already showed that that's true on the surface in terms of because it's a circular paraboloid. So then we're going from where we just proved that z is equal to r to the 4th. which, like Eileen said, is equal to r squared, because when you raise an exponent to a power, you
No,
multiply.
yeah, I got that. I just don't understand how it's 2x squared y squared.
2x squared y squared? What do you mean? There's no 2.
Like, why does z equal?
So you're just gonna stay. Okay, are we figuring out questions here?
Why is that?
Who said that?
That's just what that is.
It's just when you expand it.
The expanded.
It's, I don't
it's
know.
just
I
the
haven't really been.
expanded form.
Yeah,
when
but
you
if you're just talking about that, you can't just say it's just x to the fourth plus y to the fourth, because we know that's true, but I don't.
Well, we don't even have to look at the expanded form.
I just showed that they were equivalent. I don't really know. I just showed that they were equivalent.